Welcome to the course on soft computing techniques. This consists of 3 modules. The first module is Introduction to Fuzzy Logic. The content of the modules are first we are going to learn what is fuzzy logic, its definitions, and what are the advantages of this. Then what is the difference between precision and significance. We are going to review the classical set theory information, then we will see fuzzy set theory. We start with the inventors of the fuzzy logic theory, and the photo of that is Jodé. He is the founding father of fuzzy logic theory. Look at the numbers, citations, and H index. He has developed the concept of fuzzy logic in the year around 1965, and he presented a seminal paper on fuzzy set theory in 1965. This paper alone got citation of over 1 lakh. The other two inventors are Ibrahim Mamdani, the PhD scholar of Jodé, the first man to apply the concept of fuzzy logic theory to practical applications. Then the other one is Takaaki Sujino. So these are the 3 inventors who contributed to the development of fuzzy logic theory. We'll start with wanted to know the meaning of fuzzy logic, or what is fuzzy logic. The English meaning of the keyword fuzzy is uncertain, haze, not clear. So whenever we could not able to judge, or you cannot define, if you could not able to define correctly, the information is void, what we call it as fuzzy. Fuzzy logic is a convenient way to map an input space to an output space. This is one of the definitions of fuzzy logic. Look at the word in bold, the convenient. So it means that it is a convenient method to map an input and output space. So for any non-linear complex problem, if you know the inputs and its corresponding output sets, then you can use the fuzzy logic tool to map input and output in a convenient manner. It has been already proved that fuzzy logic has been widely applied to many non-linear solving problems. We will see later on the applications of it. Fuzzy logic is a logical system. There is no fuzziness in fuzzy logic. It is clearly proved logic and mathematically proved logic. It handles only the fuzziness present in the problem. There is no fuzziness in the fuzzy logic. It is an extension of two-valid logic or Boolean logic. Boolean logic can handle ones and zeros. Fuzzy logic can handle any number between 1 and 0. It can deal with real-world vagueness. Wherever the problem consists of vagueness or uncertainty, unable to decide upon certain factors, we could not able to precisely tell, then those factors called as uncertainty, and fuzzy logic is a better tool to deal with uncertainty present in the problem. Fuzzy logic relates objects of unsharp boundaries in which membership is a matter of degree. So if the boundary is not sharp, then you can use fuzzy logic. What are the advantages of using fuzzy logic? It is conceptually easy to understand because it is based on what we naturally speak. So anybody can understand easily. So the concept behind understanding fuzzy logic is that makes easy to understand. The mathematical concept behind fuzzy reasonings are very simple. Almost we can say it is free from mathematics. or the concept required for understanding the fuzzy logic, mathematical background requirement is very, very less. Fuzzy logic is flexible, so unlike other programming languages, fuzzy logic is very flexible. It means that once the fuzzy logic system is developed, it can be easily modified, it can be added, deleted, appended so easily. Just you can compare with any program written in C. Somebody has written a program in C and somebody else wanted to correct it, then the corrector must know the entire program, then only you could able to successfully change the program. But it is not so in fuzzy logic. Even without knowing the entire thing, how it has been developed, the user can easily change the corrections or make the corrections as per the user without knowing completely knowing the design of the entire fuzzy logic system. So this makes it's a very flexible system. It has the natural capability to handle the tolerance of imprecise data. So in real world example, all information that is used may be prone for noise or imprecise. So fuzzy logic is naturally capable of handling those imprecise data for solving the problems. It can be it can model a non-linear functions of arbitrary complexity. The benchmark problems solved by fuzzy logic controllers are cotton pole model and inverted mental model. So those two are highly non-linear problems, and these two are effectively and efficiently solved by fuzzy logic theory. So any complex non-linear problem can be solved easily and conveniently using fuzzy logic controller. Fuzzy logic can be built on the top of the experience of experts. So experts' knowledge can be coded into a fuzzy logic system easily. For example, an MBBS doctor is a pioneer in diagnosing diseases from the symptoms. So those knowledge can be converted or coded into a fuzzy logic system. There exists a fuzzy logic based illness detection model. So that can determine, if you give the type of symptoms, it will tell you the possible disease. So it has been developed by the group of doctors. So the knowledge of an expert can be coded into a fuzzy logic system, and that can be easily disseminated to other experts for using it. The biggest advantage of fuzzy logic system is it can be blended with conventional control techniques. That's why fuzzy logic has been widely used in many control applications. So you can use an existing PID controller and you can make it better using a fuzzy PID controller. There exists neural network is best for training the data, and from the trained information it can produce the output. We can, for the part of using uncertainty, you can use a fuzzy logic and you can make it as a fuzzy logic plus artificial neural network. So it is popularly called adaptive neurofuzzy inference technique. So wherever the uncertainty is present in any system, the fuzzy logic can be added to it, and you can blend with the existing system. So that makes it applicable to several areas. Fuzzy logic is based on natural language that we speak, so that makes anybody to understand and write it. Now we'll see some of the history of the fuzzy logic technology development. As I told that the fuzzy set theory was first developed by Jaudet, and he has given a paper in 1965, and then fuzzy algorithm was next paper on 73 3 and Ibrahim Hamdani used fuzzy logic controller for steam engine control in the year 1974. That is the first application of fuzzy logic theory to the practical problem. From 1980, cement control are widely used in cement plant based on fuzzy logic. Today, almost all model plant controllers, clean control works based on fuzzy logic only. The best example for application of fuzzy logic system is subways and air transportation systems. An electric train, even today, it runs based on fuzzy logic only. There is no driver in the train to control, so it is purely fuzzy logic based. So more than 25 years it is working very successfully. It is the best example for application of fuzzy logic system. As I cited earlier, there is a diagnosis illness fuzzy based system available, and automatic aircraft vehicle landing, and some of the laboratories are exclusively operating for fuzzy logic research in Japan, and they have created a fuzzy set, fuzzy TV set by Sony in the year 1990, and almost more than 250 appliances work based on fuzzy logic theory. That you may already aware that there are fuzzy based washing machine control, fuzzy based coffee maker, and so on. There are many exclusive journals available for fuzzy logic concepts. I would like to quote a statement given by Jodé that makes us to understand what is precision and significance. So Jodé says, as complexity rises, precise statement lose meaning, and meaningful statements lose precision. So it means that in any complex system, you cannot precisely write by mathematics or anything. So there is no precision in complex system. So if there is if any system can be precisely written by mathematics, then those system is not at all existing. So we will try to understand this with a simple example. A person telling the other one that look at the figure, and a mass of 1500 kilogram is approaching your head at 45.3 meters per second. So the person in the left says to the right, and before understanding what he says, definitely you won't be there. So instead, one can tell something like this. Look out, definitely he can escape. So this is, the left one is the precision, and the right one is called the significance. So in most of the engineering problem and the real world problem, we need significant information than precision information. Right. So with this we will conclude, and we will continue in the next.